This is Module 2, Lesson 5, and it's a continuation of Part 3. We're going to specifically look at some examples of the Type 1 questions where you're asked to find the probability, or find the percentage, or find the area under the curve. We are going to be utilizing the calculator for these problems, so you may want to get yours handy. Let's take a look at our problem. According to the American College Test Math, results from the 2017 ACT testing found that the students had a mean math score of 20.7 with a standard deviation of 2.0. Assume the distribution is normally distributed. And the first question says, find the probability that a randomly selected student has a math ACT score less than 19. Okay, a couple of things to point out here. If you'll remember, I mentioned to you early on that we need to know three things in order to work through these problems. We need to know that it's normally distributed, which they tell us in the problem. We need to know the mean of the distribution, which they give us in the problem. And for this one, it is 20.7. And we need to know the standard deviation, which is also given in the problem as 2.0. The wording of the question is my clue as to the command I need to use on the calculator and how I need to go about working the problem. And that phrase is find the probability. So that tells me which command I want to use. So we want to find the probability that a student has a score less than 19 on the math ACT. Now, you can also see this same problem as instead of being written in words as it is here, can also be written in symbols, and it would be written this way. The probability that X, see, let me get out of the, hold on just a minute. Let me erase that. Okay. See if I can do a little bit better job there. Okay, the probability that the student's score is less than 19. It'll also help you if you'll draw a picture of what's going on with this distribution. So we're going to draw our horizontal axis, our bell-shaped curve with the mean in the middle, which we know to be 20.7. Our point of interest in this problem is 19. So in relationship to 20.7, 19 would be on the left-hand side. So I'm going to kind of just roughly sketch in where I think 19 would be. And we want to be less than that. Remember, less than is to the left. So that's this region to the left of 19. The other thing you have to remember here is that the normal distribution is a continuous probability distribution, which means it goes on forever and ever and ever and ever. So although you can't really score negative infinity on the ACT, this distribution in theory does go out to negative infinity. So because we're asked to find the probability, we're going to be using the normal CDF command in our calculator. So what I will type, and we'll actually type it here in a minute, normal CDF, we'll get our command, and I'll show you how to do that. We'll go from negative infinity up to our value of 19. Our mean is 20.7. And our standard deviation is 2.0. Okay, so I'm going to pull up my calculator, and we're going to enter that. You may want to watch closely. Okay, remember to get to our command. It is the blue second button, so we press the blue second button, and then the button that says VARS next to the clear button, which we're really pulling up our distribution list. We're using option number 2, our normal CDF. The reason we enter the -1 E99 is because our calculator face doesn't have negative infinity. It doesn't have an infinity button. So we enter the largest number we can in the calculator. And literally we're entering -1 followed by 99 zeros. Okay, so we're doing -1. To get the E, it's the second and the decimal. 9, comma, 19, comma, the mean of 20.7, comma, and then the standard deviation of 2, and we close the parentheses and hit enter. And so we end up with a value of 0.1977 when you round it to 4 decimal places, and that's how we always round it. So we get 0.1977, which means there is approximately 20% chance a student scores less than 19 on the ACT math. Okay, that's what that means. The interpretation is we found the probability, and so that probability is this 19. This would be the answer that you would actually put on your paper, 0.1977. All right, let's look at another one. Same scenario. We still know that it is normally distributed. We still know the mean math score is 20.7, and we still know that the standard deviation is 2.0. The question says find the probability. So again, that's the clue to the command that I'm going to be using, that a randomly selected student has a math score greater than 30. So again, we can write this particular question can be written in symbols. Probability that a student's score is greater than 30. Again, we want to draw ourselves a picture of what's happening. So I'm going to draw my horizontal axis, my bell-shaped distribution. The mean is in the middle, which we know to be 20.7. With respect to 20.7, 30 would be to the right-hand side. So 30 is going to be up here somewhere. We want to be greater than 30. Greater than is to the right. So we want this region out here in what we call the tail. And again, although you can't really score positive infinity on the ACT, because this is a continuous probability distribution, it actually does go, in theory, out to the positive infinity. So again, because I'm looking for a probability, I'm going to use the normal CDF command on my calculator. We always enter the lower value first. In this case, that's 30. The upper value, which is positive infinity. The mean, which is 20.7. And the standard deviation, which is 2. Okay, I'm going to pull my calculator up again and walk you through the keystrokes. Okay, get your command. Blue second button and the VARS button next to clear. Pulling up the distribution list. Option number 2. Enter the value, the smallest value first, which is 30, comma. Again, for positive infinity, we enter 1, E, which is second, and the comma. 9, 9. Again, that's a positive 1 followed by 99 zeros. It's as big a number as we can enter. Comma, the mean of 20.7, comma, standard deviation of 2, close the parentheses, and enter. Now, be very, very careful. This is kind of a unique problem, okay? Look at the answer. 1.66149529 e to the negative 6. That e to the negative 6 at the end out there tells me that this is like a really, really small number, and the calculator has automatically converted it to scientific notation. So really the answer here is 1. So let me get my pen going on. Is 1.66 times 10 to the negative 6 power. It's a really small number. Now, the interpretation of that is you would have a decimal followed by 5 zeros. 1, 2, 3, 4, 5. And if I round, it puts it to a 2. Basically, you have to move the decimal point in 1.66 6 places to the left. And guys, for all intents and purposes, that's such a small number. The probability that a student is going to score greater than 30 on the ACT math is 0. Okay? All right.